All right. Okay, guys. So we are moving right along here. So now we've gone from just a quick review, just kind of dial it in. We've gone from the idea that f prime, which is the same as dy dx, which is the same as y prime, which is the same as the limit as h approaches 0 of the function of x plus h minus the function of x all over h. And all of these are considered derivatives. And are these make up the slope, well, not the slope, the slope of the tangent line. This is a key piece right here, guys. The slope of a tangent line, not lime, even it's written in lime, but kind of funny that I wrote lime and it's a lime color. Uh, so, slope of the tangent line at any point on the function. Okay? So, it's at any point on the function. Now, remember, a derivative means we are differentiating the function, right? So the function, we're differentiating the function. So that means that, and I'm kind of tying in all the different words, that means it's differentiable, meaning we could just take the derivative of it, and it means it has to be continuous at that point. Okay? So it has to be continuous on that specific point. So all of a sudden now we talked about limits earlier, we talked about continuity, we've talked about limits here. At the beginning of the year, we were doing lines of with equations with y1, y minus y1 equals the slope times x minus x1. And so I'm trying to bring you full circle here because I got a little bit of time. Look, here's our slope. Here's the idea of slope. This new idea of slope wraps back up to here. The fact that we're using an equation of y minus y1 equals m times x minus x1, that's how we get our equations of lines. We just got to know what a tangent and a normal line is. And then we just have to decide how to get the derivative so we can get the slope. All these things that we've done, even though they've been in like chunks and confusing at times, this is the reason. This right here is the reason we talked about limits and for continuity. And your algebra that you did the last 2 to 3 years is because we have ugly things that we have to find slope with when we do our derivatives. All right. So that's just kind of a quick overview of what we've covered so far. So now let's just look at this. I'm just going to make stuff up because it's just easier. You got a bunch of stuff to do today. And we'll do a couple in class, but I want to kind of go over a few things. Let's just find the tangent line. Let's do the tangent line at um, x equals 9. X equals 9. And let's do, and f of x is going to equal, uh, let's do one we haven't dealt with before. Let's do this. Let's do 2x. I don't know. When I make these up, sometimes they go sideways. So let's just kind of deal with this. So we need to do the tangent line. Now the tangent line, remember, if we talk about this, the tangent line is the derivative. So we have to do f prime. We need to know what f prime is. So let's just first find f prime. So f prime, so let's change this. F prime of x is going to equal, and let's just change this here. So let's rewrite this. So we have 2x to the 1/2. Square root means to the 1/2 power. Old algebra skill. See, these are all these old things. So let's just do our little multiplication here. That is 1/2 times 2x. This is where it gets a little sticky. 1/2 times 2 x to the 1 minus, I'm sorry, let me go back here, to the 1/2 minus 1. So that kind of changes some things here. So 1/2 times 2 is just 1, so we're good there, right? So we have 1, and then we have 1/2 minus 1, which is negative 1/2. So x to the negative 1/2, which that cleans up into 1 over the square root of x. Okay, you guys kind of see how I did that. It's there's a lot of algebra and just remembering some really old stuff. So the key point I want to have you guys look at right here is the fact that I changed this square root here into 1/2, and then that 1/2, because I subtract 1, that is not a good color to do with that. Because I subtracted a 1 from 1/2, it's still not a good color. Let's try it one more. There we go. I did 1/2 minus 1. I get a negative. I get a negative exponent. Now the negative exponent puts it on into the denominator if it's sitting like this, and then 1/2 becomes a square root. Okay, so like I said, lots of little algebra stuff, guys. All right, so let's clean this up. We know that f prime of x is equal to 1 over the square root of x. So this again, and I'm just going to hammer it home one more time. This is the slope at any point. So now, let me go to a different color. So now we need to know what f prime at 9 is, because 9 is the point that they want. So f prime at 9, let me write that 9 for you guys. F prime at 9 is equal to 1 over the square root of 9, which is equal to 1/3. So this is also equal to my slope of the tangent line. Okay, so this is my slope of the tangent line. So my slope of the tangent line at 9 is 1/3. So now I go back to it and go, oh, okay, let me check this out. So I'm going to write my equation of a line. Yes, I'm missing a piece, and I'm doing that on purpose, guys. So y minus, I'm missing that, equals 1/3. I got that from here, times the quantity x minus my x that I just put in, minus 9. So now my question is, they didn't give me y1. How the heck do I find it? Well, you just use your x that they want and you plug it into your original function. Key point here, original function. You have, because this is y. This is f prime. That's totally different than this one. So we're going to go back up here. And so to get this, we're going to go f of 9, not f prime, but f of 9 equals the square root of 2 times 9, and that equals the square root of 18. Leave it just like this, guys, and then put square root of 18 in there. And that's what we're dealing with. So now we've kind of cleaned all this stuff that we talked about, all this stuff, all these different things we've talked about, and we've dialed it into this particular moment where we use the power rule, we use some old algebra skills, we use our substitution methods where we plug in one thing and get out another, uh, building an equation of a line, and all of this stuff we've learned over the years, or we were supposed to learn over the years, comes into play into one problem. So that's how you find the equation of a tangent line. Well, there's my tangent line. So this is my, I don't really like the yellow. It doesn't stand out enough. That's my tangent line, right? So this is my tangent line. So let me draw a graph. Here we go. I'm drawing again. That's going to be ugly. So let's draw my tangent line. So let's just draw my graph. If you plug y equals the square root of 2x into the graph, you are going to get something that looks like this. No, not like that. Got to actually change what I'm doing here. You're going to get something that looks like this right here. It's just going to be a square root graph that looks like that. All right? It's going to look something like that. And so what we're saying is that the tangent line, back to this here. Oops, not eraser. The tangent line, which is this, at 9, does that. And let's just kind of dial this in. So so it touches right here, let's say, and that is x equals 9. That's what we use the x equals 9 for, to find this green tangent line as it touches the curve, the square root of 2x. So this is y equals the square root of 2x. And this is the tangent line right here. Okay, so that's the tangent line to this of y equals square root of 2x at 9. And then this is really, so this is the tangent line, and then I'll do a bigger point here. And this point, no, there's a lot of arrows here. This point is at 9 and the square root of 18. That's what we found all up here. Okay? All right, so let me erase a couple of things here. All right. So we know that. Now, it is asking us to find the normal line. So now we need to find the normal. I'm going to do this in a different color, and I want to match it up. I always mean to do that, and then I just start doing crazy colors because rainbows are cool. Let's just do this one. So now they want us to find the normal line, right? So we got the tangent and the normal. So the idea behind the normal is it is perpendicular to the tangent line. So really, it's perpendicular. This is supposed to be perpendicular, and it kind of sucks. Let me try that again. There we go. It's supposed to be perpendicular there. So perpendicular means it's at 90 degrees, right? So this is a 90 degree to the tangent, the green tangent line. Well, what do we know about these slopes here? That the slope of the normal, the slope of the normal is equal to the perpendicular slope of the tangent. So they're perpendicular to each other. So that means if I'm given the tangent, I flip it over and get the reciprocal. If I get the Norman, I don't even know why I write Norman there. It's normal. Uh, if I get the normal, I flip it over and get the tangent line. So we really don't have much to do here other than rewrite this thing because it goes through the same point, which is 9 and the square root of 18, right? It goes through the same point. All we need to know is the slope. Well, we got the slope right here. We just need to flip it over and change the sign. So this normal equation is y minus the square root of 18 equals -3 because I flipped the tangent slope over and made it its negative reciprocal, x minus 9. So there's my equation of the normal. There's my equation of the tangent line. Okay, guys? There's some other little tweaks to this thing that you can end up with. Let's see. I'm trying to think of any issues you run into with taking the derivatives of things. Let's just do something like this, like f of x equals let's do 1 over 2x to the third plus x squared plus the cube root of x squared. Okay, let's just kind of talk about this. So before I do anything, the power rule or anything to this, I have to kind of convert it to using some basic algebra. I can't have an exponent down here. I have to have a negative exponent. So we're going to turn this into 2x to the -3. So I'm going to move this up. So then I get a -3, which poses a few little issues. This one's fine. I got x squared. This one I have to change into a radical form here. Okay. So this number is always on the bottom and the power stays on top. So this just changes into x to the 2/3. Okay. That's always the root. And this is always the power when you write those. So now I've got this beautiful little ugly thing here. And then when I do f prime, I can actually mess around with it. And I'm going to get -3 times 2 x to the -3 minus 1 plus 2x 2 minus 1 plus 2/3 x 2/3 minus 1. See where this just keeping track of stuff is sometimes just outrageous in these things. So let's clean this up. This is going to be -6 x to the -4th plus 2x plus 2/3. 2/3 minus 1 is 1/3. X to the -1/3. Okay, so now we can leave it like that, but usually on a multiple choice, this would be like a multiple choice question. You got to clean it all up. So this becomes -6 x to the 4th plus 2x plus 2 over 3 x to the 1/3. There's my answer for f prime or y prime or dy dx or the limit definition of a derivative. Now think about this. Imagine just doing the first part, f of x plus h in this thing. That would be flat out ugly, people. That's why the power rule was invented. All right, guys. Good luck, and we'll see you guys on Tuesday.